Hi, so I'm Mrs. Sutton and I am your science teacher. If you didn't know that, here I am. And today we're going to do a video about the Molecules in Motion lab. So you should have opened this document on your computer. And our target for today is I can use observations and data to explain a scientific phenomenon. We are going to investigate the question, is the speed of water molecules different in hot and cold water? So you can watch this video or you can follow me up to my procedure and then you can try it on your own and see if you get similar data. But here we go. So I need 2 clear cups. I'm going to use these beakers, and I've got one on a hot plate to get it hot, and I have it spinning so that it got hot faster. So I have hot water and I have cold water in this container. And then I have food coloring, blue and yellow, and you need a stopwatch. So I've got my phone here so you can watch the timer. So we're going to add water to the cups, and I'll turn off my spinner. So I've got my hot water here, my cold water here. I'm going to move the hot plate out of the way so you can see the difference here. Okay. And this is hot, this is cold. I should have a label, that would be good. Let's see if I can get one. So that you can really see the difference. Hot, cold. So make sure you know which one is which. And then the procedure says, open a stopwatch and it should count up. So I'm going to use the stopwatch feature on my phone to count up. Put the cups in a safe place where you're not going to touch them for this amount of time. And then you're going to read all these directions. It says carefully drop 1 drop of yellow and 1 drop of blue into the hot water, then immediately drop 1 yellow and 1 blue in the cold water, and then start the timer. So because I'm only one person, I'm going to do the hot, then the cold, and start the timer all at the same time almost. All right. And the goal of this is to get data. If I scroll down to the next page, I'm going to let them mix. Don't mix them with your hands. You are just watching what happens in the hot and cold water. And you're recording back on your document what you notice at 1, 2, 3, 5, and 10 minutes. So if you're doing this at home, you can also do this. Keep your timer nearby and don't move your cups once you put the food coloring in, and record the data. So your data is about the minutes and what you notice in each jar. So let me get this camera as close as possible to these containers. All right, here's the stopwatch. I will leave it on while we are going, if I can get my finger to read it. All right, blue and yellow in hot, 1 drop of each. Blue and yellow in cold, 1 drop of each. And start my timer. So if you want to write about what happens right away, you can. If you're doing this at home and you have maybe not boiling water, but hot tap water, it might look slightly different. We're at about 30 seconds. And you're writing what you notice around a minute. If you noticed something right away, you could also write about that. So we're getting 10 seconds away from 1 minute. You could write now in the 1 minute after start, what's happening in the hot, what do you notice? What's happening in the cold, what do you notice? And really try to use descriptive language about the blue and the yellow, if you can still see the colors. You can pause the video if you need to right here so that you can write about 1 minute. And I will let the timer go for 10. And every 2, 3, 5, and 10, you should pause and write. political texts. So we're just past 2 minutes. Maybe you're noticing a difference in the hot or the cold from the first minute. I'm still here. I'm over here. We're at 3 minutes. You should pause, and now maybe you can zoom back in the picture in the video to back to 2 minutes. How has the cold changed, or how has the hot changed? Or you can zoom ahead to 5 minutes if you'd like. Here we are at 5 minutes. You should notice maybe some changes in the color of the cold. Pause and compare to your previous minutes. And your next recording is at 10 minutes. 10 minutes. We're right at 10 minutes. Oops. Stop. At 10 minutes, here are the hot and cold containers. The cold, I can still see a little bit of clear through. There's still some swirls of color, but I can no longer see just blue and yellow. It looks more like green altogether, but swirly. For me, the hot is entirely green. There are no swirls of color in there whatsoever. And so you should now have some data about your hot and cold at minute 1, 2, 3, 5, and 10 minutes. And if you do this at home, you can also take a picture of this. You could also pause the video for yourself and think about what that would be, that picture. You then need to answer the questions down below. What does the speed of the mixing colors tell you about the speed of molecules in hot and cold water? So why did they mix differently? I didn't stir them, I didn't touch them. Why would the hot look different so quickly than the cold? There are several variables in this experiment. The amount of water in each cup, the type of cup used, when the number of drops of food coloring, I added 1 drop of yellow and blue to each, that was it. And when the coloring was added to the water, please pick one of those and explain why in an experiment it's important to keep that the same. And if you're not sure, think about why it would be important to do it start them at the same time, or why should I not add 5 food coloring to cold and 3 to hot? Why would that not be a good idea? Just back up to number 1 for a moment. When I ask you to say that data can be the minute that you recorded in the answer. So when I said data is numbers the other day, when you were writing about data, this is the reason we have numbers here for the minute, but your observations are also data. So how is the blue and yellow swirling looking, and how are they different at minute 1 versus minute 10? How is the blue and the yellow different from minute 2 to minute 5? So that's how you should think about answering number 1, with a paragraph or so under number 1. If you continue to scroll down to part 2, you'll see that there's a link for an animation about water molecules. You can adjust the temperature to see how the water molecules are moving in that animation, what it kind of would look like inside these containers. And then you're answering 1, 2, 3, and 4 with the word increases or decreases. Down under that, you're using circles to represent water molecules. You're going to open this picture, double click it, and add circles and lines to represent what you think is happening to molecules in cold water. This is what's happening in room temperature water, and what's happening, do you think, in hot water? How would the molecules look? And if you want to take it further and move your brain a little bit deeper, let's say that you measure exactly 100 milliliters of water in a graduated cylinder. You heat up the water to 100 degrees Celsius, which is boiling, and notice that the volume increases to 104 milliliters. You should write about why you think that graduated cylinder might go up a little bit if we heat up that water. We didn't add any water, but what does heating it up mean for the molecules and the space they take up? So that's a thinking question at the end. That's your lab. We're going to work on that from Thursday and Friday. Check in on Friday. Thank you. Have a good day.